Everyone, welcome to Manufacturing Hub. This is a special episode, episode 164. We've got David Turner, who we'll introduce in just a sec. We're talking all about process engineering. Vlad and I, as we were getting ready to get on stream, we're sharing some of the stories and pictures and videos that we can go ahead and have to remind us of different places we've been, but are sometimes very difficult in order to be able to go share on social media. And that was kind of the precipice of this conversation of we got more than 160 episodes in, and I'm like, we had this really awesome conversation with David Turner at Automate, but I don't think we've talked any amount of time about process engineering. We should absolutely go ahead and do that. So if you guys are new here, welcome. If you've been here before, welcome back. We aim to have a very fun conversation, so we'll be going for the next 60 to 75 minutes. The majority of the questions and everything that we have are on LinkedIn. I know we more recently have gotten more and more folks from different platforms coming in. If you guys are on LinkedIn, or maybe Vlad will go ahead and drop some notes in the chat to make sure that the chat on LinkedIn is still connected. Sometimes it connects to our restream and we can see them all. Sometimes it doesn't connect to our restream and we can't see, we cannot see the messages. But if you guys have questions, please feel free to go ahead and throw them, especially on the LinkedIn or YouTube chat. We will do our very best to go ahead and get to those messages as we are going through this conversation. And as we've got David in here, I see some messages. I see a Derek Harrison. So I imagine Derek has commented and I just can't see it yet. And I see Gabriel in here. Thank you that. Loving the hats. We will absolutely go ahead and get into the hats in just a moment. But no, so if you guys have questions or comments, please feel free to go ahead and throw them in the comments. But without further ado, everyone, welcome to Manufacturing Hub. This is episode 164. We have David Turner on as our guest and our benefactor of these awesome hats. So, David, welcome to Manufacturing Hub. Thanks so much for being here.
Thanks for having me. I really appreciate the invite.
Yeah, I think it's going to be a really good conversation, David. I think it's very interesting what we're going to discuss on the process side. But before we get there, I do want to ask you about your background a little bit, and ultimately, how did you go through your career, and how did you start your own company? I have a few questions on that side as well.
Okay. Honestly, I'm a degree chemical engineer from Auburn and graduated back in 2003. So not the too distant future, but and then bounced around. I spent about 2 years in a carbon black plant making above ground. It was above basically coal dust used in tire manufacturing, and then went to Arizona and started working in the sulfur recovery units, doing design work, really around where the ultra low sulfur diesel came from. When that started up, we were expanding our sulfur refining, so a lot of work going on there. I spent 3 years out in Arizona, and then went to a food plant, made specialty chemicals, emulsifiers and waxes, and we did that for did a production engineering for 5 years, programming old thumb wheels and circular charts into Honeywell C200 DCS system, along with upgrades to some other PLCs. And then relocated to Atlanta, where we spent 5 years designing chemical feed systems for municipal water and pool water. Actually, got co-inventor on a patent while we were down there. So I've got just basically a special kind of chemical feeder using special chemicals, and we deployed those in the field. And most recently, before starting my own business, I spent 5 years, about 5 years in animal nutrition, making nutrients and chelated organic trace minerals for livestock. And then 2 years ago, I started up. Actually, so Turner Process Solutions started out as Automate or Die. That was my business name. That was legitimate. And I bought the website automateordie.us because Automate or Die, the other one was taken. and my emails kept getting bounced by people like all the time. I couldn't get an email through, so I had to change the business name. So went through a couple iterations, and we're at Turner Process Solutions, which I think really encompasses what we do. But that's where automate or die came from. Was when I started this company, it was we're going to automate or we're going to die. That was my mantra. And so we've kind of just some iterations over the past couple of years, but I think we've settled on a good fit for what we do.
David, I've got I guess multiple questions for you, but I'm curious, in chronological sense, right? Taking a step back, with a degree in chemical engineering, is it common to get into programming, or typically would you be, let's say, responsible for scaling production and understanding the process more than, I want to say, be in touch with the hardware and software side?
Well, so in production and process engineering, so non-discrete manufacturing. So discrete manufacturing is bottles, caps, boxes, supply chain kind of consumer packaged goods. But non-discrete is pumping, piping, and temperatures, pressures. So in the non-discrete manufacturing world, you can either take a chemical engineer and teach them electronics, or you can take an electrical engineer and teach them chemistry. So that's kind of where everything flowed through. And my experience was I went to basically a refinery support team for the sulfur recovery, and they said, okay, you're the new guy. We all know this programming, so you're going to learn the programming next. And they go off and run projects, and the new guy learns the basics. And so that's kind of where it started. And we were all chemical engineers there. And so, but it's really either a double E learning chemistry, or a chemical engineer learning electronics. And I don't know, I'm biased.
And that's very interesting, right? Because I think a few people in our, at least like circle, I believe Ali G came from a chemical background and also does a lot of sort of like automation and programming. But from what I've seen, I'd always have counterparts who were more like process or materials or, like transformation inclined, and they usually had like a chemical background, but they wouldn't necessarily be programmers in that sense. So I think it's interesting that you've made, I don't want to say that transition. I guess maybe the company you were in was very strategic about teaching you controls as well. So I think that definitely makes sense. But I guess moving, go ahead.
So no, it was great. I'm in school. We had exactly one controls class, and I hated it. Absolutely hated it. It was terrible. I sucked at it. But when you take a new job and your paycheck depends on it, you learn. When you're paying someone else, it doesn't stick as well.
Absolutely. I guess fast forward to 2 years, I guess before today, I wanted to ask you, I guess, what pushed you, I guess, or what made you think that starting your own company was the right move? And maybe did you see an opening in the market? Do you guys have some kind of differentiator? Like, what was the thought process at the time?
Honestly, it was kind of a maelstrom of a whole bunch of market indicators. I had several opportunities to bring controls engineers on and other engineers, process improvement engineers on, and we just couldn't find them. Like, they didn't exist. And so from that standpoint, I saw an opportunity to say, well, this is a hole in the market, and the company I was at was in a good position, so I left and started this company to help fill that gap.
Let me ask, I guess, another question before I pass it over to Dave. I think the common problem that a lot of, I want to say, people in our space encounter, or at least like ask questions, is how do we find, the first customers, right? And I think our work is so specialized that there's no easy answer. You can't just pick up the phone and call a facility and be like, hey, like I'm offering this type of service, maybe. So how did you make that transition, or any like learning points, how you approached that challenge?
Well, I I decided on a Tuesday to start my own business. Made phone calls and called my net. I leaned into my network. I have 20 years of industry and business relationships. So I leaned into my network. I called locally in Lexington first, and that was on a Tuesday. On a Thursday, one of the companies locally called me back saying, "Hey, I hear you're doing your own thing. What's the name of your business?" And I was like, "Automate or Die." And by the following week, I had a PO in hand. So it was really just leaning into my network and moving forward. And over the past 2 years, it's been other business relationships. It's people I've worked with, people that I've bought from, equipment vendors, and so those have been really, just that network that you build throughout your career of people that trust you and trust your work and see how you handle yourself in a business environment. So yeah, it's definitely different being on the other side for sure, because now I'm not, I was on the other side. I was production engineering. I was director of engineering. So I did the purchasing side of it, and now I know the struggles that people who are purchasing from me and from us, what they're going through and how they're having to justify, and what to look for in an ROI to help bring these projects to fruition. One, to keep food on the table, keep a roof over the head, but also to improve a process so that my clients have an easier life at work. Because there's nothing like dreading going into work, because once you step foot on there, you're fighting fires until you leave. And that's what really we want to get out of. I mean, that's no way to work.
Absolutely, David. So before I go ahead and dive more into those process engineering questions, it seems like you've moved a lot. You've worked in a bunch of different industries, which I imagine is exceptionally helpful for your clients today. Was that planned? Did you know that you wanted to live in a number of different places and work in a bunch of different industries? Can you kind of maybe take us through the thought process of, I'm going to go and start my career in here and then go work in 2 or 3 or 4 different verticals before you've managed to come up with Turner Process solutions?
Yes, it was actually. It was to an extent. I grew up in Alabama. I knew I wanted to leave Alabama. That was always that was top of the list, is I've got to get out of here. I want to experience other places. I thought it was important for me in my career growth to do that. So I spent a couple of years in Alabama working, and then went to Arizona. Spent a couple of years there working. Went to went to Pennsylvania. Spent several years there working, and was able to glean best practices from refineries, from specialty chemicals. I spent half of my career in PSM regulated environments, where that really helps structure and organize your communication process for change management. So it was really, I knew I wanted to experience different verticals, different plants. How it happened, not really as planned. It wasn't like, okay, I will spend exactly 3 years here and I'm going to go somewhere else, or spend 5 years here and go somewhere else. It wasn't planned like that. I just knew that I wanted to experience different environments.
Absolutely. No, I think that makes sense. And I know that throughout my career, I've also gotten to experience a bunch of different environments. And I think it's really interesting to go compare the environments and kind of best practices from each of the groups. I find that sometimes there are very similar best practices, and other times you run into some other questions. Here we go. We've got John here in the comments, and then this is for David. That is an Auburn reference for Vlad, who is not the largest football. Did you?
The only reason why I get that is because I've been listening to the book on Tim Cook, the new CEO of Apple. He's also from Alabama, and so that is a reference that I understand now.
But he went to Auburn, or he went to the other school in Alabama? Because
If
there's
I am not mistaken, he went to Auburn. Yes.
okay. Because there's a big difference. There are two people in Alabama, Auburn fans and Alabama fans, and I'm not sure I've met a person much in between.
They don't. You cross the border. You state your claim. Are you off for Auburn or are you for Alabama? Unfortunately, both my parents are Alabama fans.
Oh, that is a little tough, especially for the last, I don't know, entire Nick Saban era of college football for you.
Brutal. It was brutal. But you know, I'm obviously not a football player. I wanted an education, so I decided to go to Auburn for that.
Oh, okay. So
he went to Auburn also. Auburn University.
Okay, I was going to say, but before this starts to get really nasty, because I know there are Alabama fans in my feed, I want to go give the people, the listeners, what we promised. I want to go ask David, what is process engineering? This process engineering that we talk about, can you give us maybe a little bit of an overview, and then we can dig into that?
Well, process engineering in its entirety is basically making designing a system to make a product. You know, whether it's putting eggs in a basket and making powdered eggs at the end, or putting two chemicals together and making rubber at the end. Whatever it is, it's developing a process to manufacture a given good. And what we do typically in process engineering is we take someone else's process that they've done and we make it better. Someone who's, a plant's been running for 40 years and like, well, it's steadily, yield is steadily declined yield, the amount of energy you put in versus the amount of product you get out, energy goes up and product goes down, and that's your yield. Like, well, it keeps going down. How do we get better? Or maybe we've been running this plant for 40 years and we need a new product. We'll go in and help develop that as well. But it's really looking at the manufacturing environment, the equipment specifically, pumps, sensors, piping, and developing a better way to do it. Or a different way, because a lot of times what happens is, someone buys a plant, they develop a system to manufacture X, and over the past 20 years, they're now manufacturing X, Y, and Z. Well, Y and Z aren't really made with that equipment. They just do it because they could. And so it's like saying, okay, well, when you run this product, you have to run it this way. Yes. So it's really improving the processes that happen on that side of like just tweaking sensors, or maybe changing out a piece of equipment. Maybe the mixers are wrong or something like that, where it's designed for liquid and you're doing solids now. And then there's, if you take a step back, it's also following product flow in your system. So it's like if it starts in your shipping dock or your receiving dock and it goes through the process and comes out your shipping dock, like what does that look like? Because we do a lot of process mapping, which says, okay, well, it doesn't go from point A to point B to point C in a straight line. It typically goes from point A to point B to A.1 to B.1, and it goes back and forth as it zigzags across. And every time it crosses its own path, you've wasted time, wasted some sort of energy. So it's like, how do you streamline those? And we that's part of process engineering as well, is developing a more streamlined approach. And that's huge with other process improvement methodologies as well.
If I can, I guess, like, just to clarify some distinction, David, because I think we've talked a little bit about discrete versus continuous versus like batching. Do you also put in, I guess, like, let's say a palletizing or a like packaging system as a process, or you would be a bit less involved in those and more involved in sort of the chemical transformations and sort of more like continuous and batching? I guess, like, what's the scope that you see process to fit in?
It's typically getting the product and presenting it to the packaging machine. So everything in bulk material handling. So typically, you know, plants are designed around, you know, somewhere in the middle of it's where the packaging line ends up. You know, you got a guy putting dirt in a bag, or, you know, whatever your product is, you're putting it in a bag, you're putting it in a bottle, and they do it very effectively manually. So if you want to improve your process, you've got to put in this monster automated system now, because instead of having this one guy in the middle of your plant, you've got this line that's going to, not only is going to put your product in a package, it's going to put your package in a box and put that box on a pallet. So now you're doing a lot more in one given area. It won't fit in the middle of a plant. So what we've done is, you know, we've partnered with some integrators who make packaging systems, and they make packaging systems very well, but they don't have the expertise to present the product to the system. So we'll go through and we'll design processes that'll present the product to the system. We'll also design processes around bulk material handling, and dust collection. So dust is, you know, obviously dust is bad. And so we'll design dust collection systems to be able to remove and keep the area operator safe. So we've only just started getting into palletizing specifically, and it was really geared around a specific customer need. And with the warehousing the way it is today, and ergonomics and, you know, labor, I think it made a good fit for us to be able to provide an additional tool in our tool belt for our clients. And so we partnered with Obo Robotics recently, because they have a nice palletizer system. You know, it basically deploys in a day. You can have it, if you have a spot on your warehouse floor, it can be palletizing 20 kg in smaller boxes in less than 8 hours.
Yeah, and it's very interesting, right? Because I went from a very discrete type of process where, you know, we were making widgets to being fairly involved in these like P&ID diagrams and trying to understand like product flows. And I don't want to say it's night and day, but the challenges are quite different. The instrumentation is also different, right? And it has its own set of, I guess, I want to say, fundamentals that you need to know. But sorry, Dave, go ahead.
No, I was going to say, you know, it's when you're working with inside the pipe, what I like to call inside the pipe processes, it's completely different. It's a different animal when you're dealing with discrete packaged goods, because, you know, if you have packages on a conveyor, you know, you can see them. They're there or they're not. If it's in a pipe, you can't see it. You don't know if it's there or not. Maybe the pump's broken. Maybe it's plugged. You don't know unless you look at the sensor technologies that are out there and say, okay, well, this temperature says it's 100 degrees, but this temperature over here before the pump said this, 200 degrees. So it must be plugged, or something else is going on. So you have to like know your process holistically, in a level of detail that, most people, when you're walking by a pipe, you don't know what's in it. You don't know how fast it's flowing. And, you've got to walk those down. If you're walking by a conveyor, you know if it's running or not. You can see, hey, there's a box on it. There's a bottle on it. It's running, or maybe the bottle fell over and it's plugged up. So you walk over there, you pick it up, and it keeps rolling. Or maybe it's overhead and you're having to shove a broomstick to pop the bottle off of it.
Right. Dave, thoughts?
Interesting. No, I guess I've never really considered there being huge differences between like in pipe versus not in pipe. I guess you're correct. You can't see it, but I always generally assume that it's working and or flowing unless we get an alarm or there is a problem, and then you have to go use similar tools, etc., in order to go figure out if we're moving, and if we're not moving, where we are stuck.
Right.
But no,
well, you're absolutely right about that. But just think one step back: is who did that alarm?
Mm-hmm.
Like someone
Vlad.
had to.
That's how I know it works perfectly.
Right. Someone had to go through and say, well, this is a process upset condition, so we got to program an alarm in based on motor amps is a big one that we use quite regularly. So it's either too high or too low, and so we got to know those aspects to go look at it, or temperature.
Yep. No, absolutely. I would agree with that. Let me go ask you the question, David. You talked about doing a bunch of work on some older facilities, right? So if a facility is 40 years old, they're probably not running exactly the same. I imagine the raw materials have had at least one or two changes over the course of those 40 years. What sort of trends are you seeing with older facilities versus newer facilities being stood up? Are you seeing older facilities looking to invest money and time into coming up to kind of more normal standards, or are you seeing them saying we're going to go continue to run maybe until we can't run profitably?
It's really a blend of all of it.
Yep.
I've gone into facilities, and it's a manual casting plant, and it's like, hey, for 10 grand we can add some information to this, so what your throughput is and how fast you're running and how much you're throwing away, and we can improve this process 10%. Now we don't have 10 grand to spend. It's like, or it's other facilities where it's like, well, we know we're terrible. Let's throw $100,000 at it to get us up to speed, because right now this system, this PLC is dying. We're going to eBay. If it dies, we make zero cash. So
yes,
we've got to get it up and running. So I've seen the full gamut where the smaller companies are, they're throwing warm bodies at it because that's what they can afford. But it's trying to, and I've said this on, I think Larry Stepanak's, I butcher his last name, it's redefining what broken is. Just because it's producing doesn't mean it's not broken. Like,
okay,
you can be, if it's producing, say, 80% of what it used to, well, people don't care. They're like, okay, well, now that's just, it's 30 years old. It's gonna run like crap. Not necessarily. It was designed to run at a certain rate. Let's look at those design characteristics and figure out why. So it's rehabbing those, and we've actually invested in some process modeling, Aspen Plus, which is a very robust process modeling tool to figure those items out. Like, why is it running like this? How do we make it better? Because doing offline modeling is a lot cheaper for the client than saying, hey, can I go turn this valve a little bit, see what happens? People hate it when you do that.
If I can add to that, David, I think a lot of times manufacturers don't even know that their assets are running not at the rated speeds, right? Because those changes are made over the years. They're made very sporadically. They're not necessarily logged anywhere. And typically they don't have the data, like you were saying, like you can come in and extract the data, but a lot of them currently don't, right? The reality is someone on, a certain shift would tweak the speed of the machine, and obviously they're going to run better if they're running slower, right? From the mechanical standpoint, electrical, vision system, but they're not producing as much. So you almost have this like gain in it's producing technically better from an output standpoint, but it's producing a lot slower. So it's that's why you need to come in and actually audit the facility, understand the bottlenecks, and there's a lot to that in terms of the science.
Right, you're 100% right, and we see that even in my last 20 years. It was always, a lot of processes were operator dependent, and it's not having standardized processes, and it's not having a way to control your process that really allows operators to run it how they feel it best runs. And no fault to the operators. Most of these guys were in the plants, a lot longer than I was, and they knew how to run the system for what they wanted to do with it. And it was trying to glean that information out to say, okay, well, what are you doing and why? Okay, well, if you turn this valve, it actually produces, it heats it up faster. Well, why does it do that? Well, you dig through why, and is that better or worse? I mean, we found some processes where we were throwing in a reagent too fast or too soon. We hadn't reached the activation energy, and so it was causing a lot of foaming. But if we heated it up a little bit more, like 10 degrees, all the foaming stopped, because what was happening was it couldn't react yet. It wasn't hot enough to do the reaction it needed to do inside the vessel. So as soon as it did, everything started reacting, and the foam would be terrible. But just looking at that, and honestly, that improved production by slowing down the feed until after you give it an extra 10 minutes to heat up.
Right.
So your
let
yield.
me ask you a follow-up, I guess, related to that, but also I think we have a question on the communication side, but I want to change that a little bit and ask you the question of, when you're auditing a process, right? When you're trying to understand maybe where the opportunities lie or where the current problems are, what is your in general approach, right? Do you talk to the plant managers? Do you usually want to talk to operations, the maintenance guys, the operators, all of the above? Do you want to observe the process yourself? Maybe deploy your tool that you've mentioned that can simulate the process. What does that? And again, obviously, that could be an entire like 3 hours on its own. But maybe in a general sense, what does a process audit look like?
It's really geared around the equipment or a given product, depending on what we're going in to evaluate. But you really, you've got to look at the P&IDs. You've got to know what you're walking into as far as what unit processes are out there. Is it spray drying? Is it tower drying? Is it just mixing? Is there some sort of oven? Is there a furnace? So just understanding the different unit operations that you could walk into, so that you can kind of start visualizing the product flow. And then you want to walk the floor with the engineers. Walk the floor with the engineer, have him explain the process to you, and then walk the floor with an operator and have him explain the process of what he's doing. And usually that's about 3 or 4 different operators, because they're all doing different areas of the process. And then you can start getting an idea of what's really going on. And from there, you want to talk to maintenance a little bit. Not really on the initial audits, but on follow-up visits, maintenance is going to be critical, because maybe someone on night shift is changing the pump bearings out weekly, and no one ever knows. They just know they got a lot of downtime. They just don't know what's going on. And so digging into that information, and you don't really know what to ask until you walk the process and figure it out and talk to the operators and the engineering group, before you start bringing maintenance and asking the right questions. But anyone who physically touches the equipment are the critical points for an audit.
Do you usually get a lot of data on that side? I guess I'm assuming not, but are you ever like surprised with plants that have good like MES or SCADA kind of layouts, and it's almost like better to look at them versus talk to people?
If you have SCADA, fantastic. Those will help you. Like the floor walks will help you put the pieces together from SCADA, because especially with trends, because if you look at trends don't lie. They can't. I mean, it's time-based data. So as you watch something and you say, okay, well at 9 o'clock, this goes haywire every night. Oh, or only 4 nights a week it goes haywire. Okay, well, shifts are 4-day shifts. You can tell someone's doing something. So maybe they have a way of running a piece of equipment that others don't do. And better or worse, it's just you can pinpoint specific actions on the time-based data by walking through the process with the operators or engineers, because maybe they shut down a process when you're looking at it, you're like, well, why did it shut down? Well, there was an alarm or some other event. Maybe the other side of the plant caught fire, and so maybe the operators don't know, maybe engineers know, or maintenance knows. So it's if you have the data, it's great, but without the interaction from your floor audit, the data doesn't really. There's not a lot of hope for identifying root causes for why it's not running. If that's the reason you're going for the audit, is it's not running well, or there's other issues that keep popping up.
I think that makes sense. Dave, thoughts?
Absolutely. So I like your comment, David, about going and talking to the engineers and walking the process, and then going and walking the process with the operators. I do that a lot. I guess my question for you is, how often do you have a very similar process definition from both the engineers and the operators?
Yes.
Okay. I guess I will extrapolate on that first, especially for an engineering team or an operator team that doesn't have a bunch of combined experience. Like, so sometimes I'll work with engineers who are very young and understand maybe high level of the process, and the operators really know all of the insides of the process. Other times I will do the opposite of the engineers actually have built the process and they know it really well. And you go and you talk to the operators and you very easily understand what the problem is. It's that somewhere there is a disconnect in which maybe we don't understand or agree with how the process is supposed to work. And that is why we continue to change set points. And that's why we continue to shoot ourselves in the proverbial foot.
No, you're absolutely right. The operators are physically touching the equipment every day. Mm-hmm. and they're intimately involved. And 20 years ago, 30 years ago, operators were there and they knew the equipment. They were trained by people who knew the equipment. Nowadays, it's a lot harder because a lot of plants that I go into don't have a formalized training plan. It's you throw an operator to the wolves, and they get trained by someone who was trained by someone who was only there 3 years. Mm-hmm. And so there's no formalized training plan, and that leads to bad habits. And it's part of what you got to help. You got to help them to recognize bad habits, and those happen. Or on the other side of that is engineers who are fresh out of school. I was a fresh out of school engineer. I didn't know jack when I went to a plant. I mean, my first plant, I was trained by the operators who'd been there 8 years, and they mentored me, and I really appreciate it. They taught me everything I knew about what not to touch, what I could touch, and how to interpolate the information from the equipment. Like, well, that sounds weird. Okay, well, let's look at it. And that's the operators and the engineers. They rarely see eye to eye, and it's usually because of experience. If you have an experienced engineering team and experienced operators, those plants hum. I mean, I don't see those because they don't have any issues.
Absolutely. I agree. I also normally don't see those guys because they also don't have any issues. I have a funny story that comes by a guy named Dan. I did some work with him once, and he said basically he was I think in college, end of college, beginning of grad school. Recently had a new baby. Was working third shift at the milk bottling, the local milk bottling plant. And when he came on, there was a guy named Jose that taught him, and Dan didn't speak any Spanish and Jose spoke very little English, but Dan was coming on and Jose was getting a promotion. And because of this, Jose had to go teach Dan. And basically the only thing he was told is that if he gets really far behind on the line with the process he was manually doing, just to go hit the red button. Now, it wasn't until years later that Dan came to this shocking realization that the red button was the e-stop, right? And so he probably smashed the e-stop 3 to 5 times every shift because he was continuously getting behind because he's not as fast as everyone else. And he's like, wow, this is probably tens or hundreds of thousands of dollars in cost and damage in order to basically every time he went to go hit that. So absolutely agree. There are some operators who are your best assets there, but there is maybe something that that we should all take with a grain of salt, and or the need for formalized training, especially
Mhm.
for some newer folks, especially around catastrophic downtime and safety equipment and things along those lines. I do want to ask you the question. I feel like we've touched on it, but I want to make sure that we ask the question so that if someone is listening and doesn't know, David, why is process engineering important? Why should people care?
The biggest one is so people don't die. I think that's critical.
Yeah.
Yeah, you've seen YouTube videos of, heck, even turkey frying on your driveway. Like that's a process that could be engineered properly, and people do it. I mean, very rudimentary, and they set their driveway on fire. They set their house on fire because they didn't do the simple calculation of a volume. It's you got a 12-pound turkey that's going to take up a certain volume. You got a 5-gallon bucket with boiling oil in it. You can't fill it to the top. So just a simple example of that. A certain level of process engineering to not set your house on fire. So that it's important because when we're dealing with certain chemicals and certain chemistries, if you don't look at the process and say, okay, well, this can't handle this pressure, or this can't handle this temperature, let's change the pipe out. Let's change out the equipment, or let's redesign this so that it can. Something like that is really critical. And the first stage of process engineering is safety. The next stage would be throughput. Where you want to engineer it so that it can make the product as quickly as possible or as efficiently as possible. And then you want to look through, okay, quality wise, let's engineer this process to improve our quality so that instead of having a quality range of this, it's plus or minus 20%, we can get it down to plus or minus 5%. And that engineered process now runs so tight that it's at a higher quality, so you can actually sell it for more. So it's at a premium product now because it's a higher quality. Everyone pays for quality. And so those are the reasons why you got to look at it: safety, throughput or yield, and quality.
As a follow-up, I think, one of the methodologies that we've discussed and that you know very well, all three of us know very well, Lean Six Sigma, which sort of dictates how process engineering to some extent, I want to say, is managed. And, we're not going to go into all the details, but I'm curious, both of your thoughts, I guess, on Lean Six Sigma, but also some of the other tools that are also listed on our file. I came through IWS because that's the P&G's flavor of Lean Six Sigma. But I'm curious, again, how have these, I want to say, tools maybe helped you in certain situations in facilities, and maybe where do they lack? And again, what have you seen that could be improved upon from those methodologies?
Oof, I've seen it effectively introduced, and I've seen it ineffectively introduced. Lean Six Sigma is a way of improving your quality through certain methodologies around the process improvements. So you're looking at downtime. You're looking at why is this down? So there's a process called the 5 whys. Well, this broke. Well, why did it break? It broke because this part burned up. Well, why did that part burn up? Well, because the feed to it was bad, or you dig down to 5 whys for a root cause analysis. I think from a root cause analysis, Lean Six Sigma provides a multitude of tools that are very effective. From a organizational standpoint, you go to your yellow belt 5S stations, and you're very effective keeping your workplace clean, tidy, where you can always find your tools, because people get paid for the part they make, not for looking for the tools. So that was a big driver. I worked at a company where the CEO was very, very supportive of Lean Six Sigma. Every plant had a black belt. Every engineer was a green belt. Every operator was a yellow belt. Every office person went through white belt training. So everyone was trained in the methodologies so that we could all speak the same language and be effective. That CEO left after, the typical 3 to 5 years. CEOs change for publicly traded companies. The next CEO didn't care. That was not his priority. So everything that had been done with the plants as we grew through that process stopped. There was no support. So the people who were in place at the time were very effective, but as new people got put into positions, they did not speak the same language as far as process improvement goes. And so it was a different environment by the end. So I think, from that standpoint, it can be implemented very effectively. Unfortunately, there's some times where they say, Lean Six Sigma is just head cutting measures. It's just reduce head count, do more with less, and be effective. Not the case. There's so much. It's once you get into green and black belt, it's all about statistics. It's a lot of math, because you're basically taking statistics to say, what can your process statistically do, and how do you improve the odds that you're going to make a quality product?
That's where the name comes from, right? Six Sigma, that's 6 standard deviations from
correct.
Yes.
Yep.
Dave, thoughts?
So I absolutely agree with David that if implemented well and implemented across the organization, it can be effective. I guess most of my experience with Lean or Six Sigma or LSS or TPM or any of these other acronyms is kind of to the end part of David's point of we come and we do it for a little while, and maybe we get a bump or some gains, and then it is no longer the what do I want to say? It's no longer kind of leadership ownership's initiative, and then it just kind of goes and dies off, right? And so I have worked in the past with a bunch of guys who come in, and you go have the conversation of like, let's go ahead and look at this. And for me, it's never a Lean or LSS or any of those particular avenues, but it's always, hey, look at the wall behind us. Here are the last 5 initiatives. They've all failed between 6 and 24 months. Why should we be here looking at potentially going to do this again? So I guess I see a lot of that. I also see the concept of, hey, we want, all of our engineers or all of this group to go be black belts. But in order to be a black belt, you have to have some number of years or decades of experience at our organization. And we're only going to teach kind of our flavor of Lean Six Sigma or any of these other tools. And there is no additional kind of intrinsic benefit. It's basically just the internal training tool that we have called a Lean Six Sigma black belt. So I would say on that side, it's really important to understand why you're going down that path before we pick an acronym and kind of go and move forward with that. And I've known people who have worked I know people who have successfully worked in all of these different arenas, and they're absolutely great tools. Like 5S's, like Dave talked about earlier. I think it's absolutely fantastic. Many of our listeners may not believe the amount of things you can go fix in a facility when the first thing you do is look at it and it's disgusting, and we say the first thing we do is clean this, right? Lots of times cleaning it and putting everything where it needs to go and going and replacing the 36% of tools that have gone on walkabout and are sitting on someone's truck or sitting on the dresser at home because they live in the back pocket, and then we walk home with them. it solves a lot of kind of very basic problems, but that is kind of very much only the first step. But if you can get it to the point of we have ingrained a lot of these things into the different facilities, I find that really successful. At one of the facilities I worked at, who Lean Six Sigma or TPM was something that they failed, I don't know, 10 years ago. They have the best boards with kind of cutouts for tools that I have ever seen. This is years after Lean Six Sigma or TPM are no longer things. And the tools are always there, right? Like they rotate operators shockingly frequently, but the tools are still there, right? So that in my mind is a win. Even if most people aren't able to go relegate this back to the TPM or the Lean Six Sigma implementation that we did a bunch of years ago.
Right. And I mean, if you seeing the tools still there after 10 years or however many years,
Yep.
it's the training of the operators, it's the ownership of the plant. Like these guys, tools will go on walkabouts if they're not being held accountable. So, I mean, the operators understand the need to have these tools where they are, and the management understands the need to have these tools where they are. So it's really both sides offering the right training to keep everything together and the accountability to do it, because someone's still there saying, no, this is where it goes. Someone walked by, saw it sitting there and said, oh, I got to put this back, because it doesn't happen on its own. Those shadow bars, it's not just one person, it's several people looking and saying, this isn't right, let me fix it. And it's that culture. It doesn't grow overnight, and two, it can only be sustained if the right people are sustaining it. And that's honestly, it's a lot of it is driven by management.
And I think that's a very important piece, David, right? Like I was going to say, that's where at least my experience has been. And it's not about the tools. And when I say tools, I'm not talking about the tools inside of 5S boards, but the tools from the Lean Six Sigma methodologies are rather, I want to say, like simplistic, right? They're simple to understand, I think, in a general sense. And sometimes in your early career, at least speaking for myself, you almost think, well, like, this is ridiculous. Like, why do I need a 5Y or 6W2H or whatever, like fishbone diagram? But I think you think with the mindset of everyone thinks that way. You don't think of, at 2 a.m. when I'm struggling to figure out this machine, I have the structured process and it helps me kind of get through this a little bit easier. That's what, like, the cultural shift is all about. And I think it takes longer than people anticipate. So a lot of times they get excited by, hey, we're going to print out these tools, we're going to bring in someone who's going to explain to them. And I think that's the secret sauce, where in reality, it's that whole like reinforcement approach. It's that change management approach, which takes, I think, in my opinion, you see kind of a decrease in productivity before you see something trend upwards, which can take, months, if not several years, depending on the process, facility, who's training, etc.
Yeah, you're 100% right. There is a decrease before there's an increase, because you're taking those people and training them. You're taking those resources and fixing them, so they have to go down before they can go up.
Yep.
And if I may, I was going to say, if I can just go add, I love the 5Ys and then the 6W2Hs and all of those. I'm a big fan of those tools, but to that point, I see more people print out the pages and pencil whip them than I see people actually able to go through them successfully. And that is another pet peeve of mine. You can't sit down and do 5Ys in 20 minutes. I have, in fact, had groups who want to come in and literally had 20 minutes blocked out of, we're going to go train people on 5Y. And I'm like, if you think you can train a group of people in 20 minutes on this, you don't understand the process well enough to even like be part of the conversation, much less to go through the process of training other people, right? Like they're generally a bunch of hours or perhaps multiple days as we go through the process, and actually like many times it's a couple of hours until you can define what actually happened before you can go start said process. And so the tools are really simplistic in theory. The actual going through the process to use the tools much more difficult. I have seen people and have had to reject some of these who should have known better because the answers they came back with were just completely impossible and way too simplistic for like the second why, much less being able to go get to the fifth why. It is much more difficult than let me go answer very surface level questions.
Yeah, definitely.
Right. Yeah.
Let me bring in this question. Oh, sorry, David, you had a comment on?
No, I was just going to say that, you know, very, very rarely can you enter a 5Y without already and know that the answer already. Like the 5Y is to define the answer. A lot of people come into the 5Y saying, well, this is the culprit. I'm going to fix this. Well, time out. Maybe it's not.
Maybe it's not. It's in fact probably not. If you knew what the answer was, you should have fixed it before we had this problem.
Exactly.
There's a question in chat, which is a fairly long question. I'm going to try my best to paraphrase this for David. Long story short, I guess, when an engineer is firefighting at the facility, right? Like we discussed that's not the state we want to be in. And I know that many engineers, after they graduate, depending on, you know, where they end up, they might be thrown to the wolves, as we've discussed with operators as well. So maybe any advice you can give to engineers being put in those types of positions where they just are struggling on the electrical front, the process front, machine front, like maybe how do you start in those positions?
That's a tough one because it's very company dependent. You know, I've been in facilities where operators are great, management's terrible, and just be like, I'm just going to hang out with you guys and we're going to get this stuff resolved, and maybe we just bring them in at the end. Or, you know, I've been where it's like, man, these operators, they weren't trained right. We got to get them training. It's going to take forever. So then you got to get buy-in from it. But when you go into a facility, it's really culture driven. If you're struggling, you know, when I was a new grad, I was very fortunate that I went into a facility where the operators welcomed me in and quite honestly, I was going to be working alongside them on swing shift. So, you know, we're working midnight 7 days in a row together. So they wanted me. Oh, it was brutal. But they wanted me to be as knowledgeable as possible because I was leading them. Like my job was to be their boss, and they're like, it makes it easier on them when I know what I'm doing. So I walked around with them for 8 weeks and learned their job. But the next place I went, it was welcoming again. And it was great. And then I went to a facility where engineers were hated. And, you know, I went in and I was like, hey guys, and they're like, go away. And, you know, I struggled learning the processes because the people who knew them didn't want to give them up. It was the culture that was driven by the plant. And so it was, you know, building that rapport with the people who know. You finding that person that can mentor you. Recognizing openly that I didn't know shit. Pardon my English. But I didn't know anything. And and as an engineer spending 5 years in school, I was supposed to know. No, you're not. I can write calculations on paper all day long. But going into a facility, knowing what's running and what's not, it takes time to learn, and being open to learn from the people who know. And sometimes that's the engineers, if they've been there long enough. Most of the times it's the operators who are touching that equipment every day. So, and it's just building that rapport and finding the person who knows and being their friend. That's the only way to get to it. Otherwise, you're gonna struggle.
If I can add a short comment to that, David. I think also systems integrators, at least for me, have been very important, because I think the people at the plant don't necessarily always touch the equipment from the software standpoint, at least. Whereas, systems integrators come in and have a lot more knowledge of the systems. And so building, I want to say, relationships with them has been key, at least for me as well, because like I said, they almost held the keys to the castle in many facilities, right? So it's not just like operators and engineers understand the general process, but for me, integrators were also very important.
Right. And I didn't deal, we didn't have integrators until, like, I never dealt with integrators because we always did everything in-house. So every facility I worked at, we were doing it, either we were figuring out DIY style on our own, or we already had people who knew what was going on, and we were building our project teams together and getting work done.
Gotcha.
There was a handful, like, I think once I had a system integrator in the plant, and basically it was programming an Allen Bradley control panel that we were upgrading, because everything was Honeywell except for this one system, which was done by a system integrator, and and partnering with not the original, some other guy, to get the work done. And it was honestly, it was rebuilding it from scratch, because we didn't have any of that information. It's like, well, let's figure this out. What's this button do?
We've all been there. Yeah.
Yeah, absolutely. Certainly all been there. That's where some of the best stories come from, assuming that you make it out whole. But speaking of which, there were a couple of comments, specific comments that I feel the need to go call out in here. So talking about e-stops bypassed and 110 volt running through 20 AWG wires, kind of very safety and scary stuff. They're saying they're overwhelmed, and where do you start? I would say, if health and safety exists, go talk to them. When you get to the point of bypassing e-stops, that becomes the someone is going to die sort of 100%. Situation. And so that is why I wanted to go call that out, is if you live in the US, if health and safety exists, go talk to them. And if no one seems to care, either call OSHA or start looking for a new job, which is kind of like the best recommendation. There is nothing that you can do in a facility that is worth dying over, or putting yourself in a position in which you can, potentially die. I normally tell people to stay away, even if a safety were to fail, if something bad could happen, to go stay away. But if safeties are bypassed, and if we're running, I mean, I guess we're talking about 110 volts. So I would imagine this is the U.S. or North America, is stay away from those. You may absolutely be overwhelmed, but take some deep breaths. Realize that at the end of the day, you can solve 1,000 problems today, and you'll walk into 1,002 tomorrow. That really doesn't matter. Yes, I felt compelled to go ahead and make that statement.
Yeah, I didn't see that comment. I said I didn't see that comment, but you're absolutely right. If safeties are bypassed, stop. You can't. And if no one's going to listen to you above you, then there's always OSHA. Unfortunately, there's a lot of risk with your job in that, because they'll throw you under the bus faster than you can run away. But
absolutely,
you're 100% right. There's nothing in a facility that's worth dying over, period. Because if you leave, they'll replace you tomorrow.
Mm-hmm.
But if you don't, and you die, then your family can't replace you. So
absolutely.
I mean, safety, I've worked in some sketchy places, and identifying and fixing those is critical.
Yes,
because
I have left
people
places. Yes, I have left places because I've been worried that people are going to go die, and I'm not going to be involved in that. And if leadership doesn't seem to care as much as I do, that's not the sort of place that I need to go spend my time. So, thank you for those comments, David. I want to go have one last conversation before we go ask you the final questions, and I feel like Vernon has set us up really well. So Vernon is saying, when getting new problems or projects from clients, what's the decision maker in saying that we're going to go figure this out ourselves versus calling in some help with integrators? And that very much goes to kind of the conversation that I wanted to make sure that we hit of, if you're an end user, do you want to use internal talent versus external service providers on that process engineering talent? So we'll open it up to you, David.
There's two decision points to make. The first one is, do you have the skill sets in house?
Mm-hmm.
I mean, you might not. And the second one is, how much money are you willing to spend on it? Because for me, being on the other side of it, when I was in the facilities, if I could have an engineer who knew the process, fix it ourselves, then that was golden, because one, it was cheaper, and two, I kept that information. I kept that experience that stayed with the plant. Nowadays, it doesn't really matter, because if you can afford it, to go outsource it, because you're probably going to lose your engineer in 3 years, because they're going to go jump ship anyways. Engineers, not just engineers, everyone, absolutely everyone. Mm-hmm. 3 to 5 years is all you get somebody. So that experience is going to walk out the door anyways. So there's no benefit in today's day and age to build a team that will be there for 20 years. So outsourcing it makes a lot of sense, because people like me, I've got 20 years experience in a variety of different areas, being able to go into a facility, regardless of the facility, and saying, okay, let's organize a game plan to fix this problem. Mm-hmm. Let's do it. And putting the right people in place, providing the right experience to resolve that issue, one, more quickly, and two, at a cost advantage, because now downtime has cost. Poor yields have cost. They're hidden. You don't know them, but they're there. So if you're producing at 80% when you be producing at 100% capacity, there's a 20% loss in your bottom line. So, at that point, the faster you can get back to 100%, the sooner you stop losing money, because everything below. Go ahead.
You want to go, or you want me to go, Vlad?
Go ahead, Vlad. I'll pick.
So, David, I think that definitely makes sense. The point I will add, right, is I think, like any other relationship with systems integrators, I don't think you want to bring them in where, let's call it, shit hits the fan, or it's a critical project, right? So what I would typically advise manufacturers do is bring them in on projects you are familiar with to sort of trial the integrator, right? So you bring them on a familiar project that is low risk, that's going to be, I don't know, maybe like a startup activity, and see how they handle like your environment. They get familiar with your engineers, operators, etc., so that when there is a need to then bring someone with that extra skill set, you have at least established some relationship. Because I think a lot of manufacturers expect to be able to just pick up the phone and call you like, hey, can you fly over tomorrow? And yes, you probably will, but you would not have that, even, again, like less tangible, like I said, like items like know the process, like having walked the lines, having like shaken the hands of a few operators, right? And I think people sometimes underestimate that that's almost an investment in the relationship, and see it almost as a like one cost for that critical project. So that's, anyways, like that's what I would advise people usually do before they get into that need, per like Vernon's question. Dave?
I think both of them are good points. I think David is super realistic. I would say, kind of specifically talking to Vernon and perhaps other end users, if you have the internal engineering talent to do it, you probably want to go do it internally, right? If you somehow manage to still have an engineering team and an engineering budget to go build the team and keep the team together, you've done it in order to have these projects internal. As we were talking earlier, that is not really the case for almost any group nowadays, because we've gutted a whole bunch of that engineering internal talent over the last, I don't know, 20 years for many of these groups, and it just doesn't exist. So if you don't have that, hopefully you have the talent to go define the scope and go manage the project internally, right? So like, if you don't go find an integrator, go find a partner. Hopefully it's a partner that can be your long-term partner for this type of projects, but have someone or someone's that can manage it internally. If you don't have that, please go find someone that is in process engineering as a consultant who understands your process to come help you define the scope. And as if you decide to go with them, or you decide to keep them on to help manage the project, that is absolutely the best way to go about doing it. Otherwise, you're going to have a whole bunch of junior engineers come together, come up with this Rube Goldberg machine of a project, and then be unable to go deliver the project because it never made sense to begin with. And you're going to have time overruns and cost overruns, and you're still going to be running at 60% of production line because you're attempting to go fix a critical solution.
Yeah, what's that that YouTube video of three experienced soccer players and 100 little kids running around?
Yeah, absolutely. David, this has been awesome for all of our listeners. I think we hit maybe 50% of the items that we were hoping to hit with David. I feel like we were a little aggressive in our hopes, and we've had so many great questions and comments.
Yeah,
from all of you.
Half the sheet we didn't even touch.
Absolutely. But we do want to at least come to some semblance of our normal 75-ish minutes for the listeners. So, David, we want to go ask you the questions. We want to go ask you the questions that we get to ask all of our guests. First, like in your mind, what is the future of process engineering?
I think what I'm seeing is there's a lot of reshoring of manufacturing, which is great. I think, obviously supply chain issues around 2020 really, and the post-COVID world have really brought a lot of manufacturing back to the States, and so I think from that standpoint it's going to grow, and just like any trade, it's going to suffer without more blood in the wall, new blood coming into the industry. And honestly, I think that leads to more automation long term. And your automation is only as good as the person programming it. So if you got a bunch of junior people who don't know how the valve is supposed to work and when, then you're going to suffer until these guys get spun up appropriately as well. So no, I see that the future is growing. It's great to see more manufacturing come back to the States. I know that there's billions of dollars being invested here locally in Lexington for manufacturing, and I know that we're not even the tip of the iceberg on that.
Absolutely. No, I think that's a good prediction. I think it goes into the next question, which we always like to ask our guests for some career advice. So if someone is listening and maybe they're into engineering, maybe they're in kind of early to mid-career, maybe they've spent more time on the operations side and have found this What is Process Engineering podcast because they find it interesting. What's your best advice for someone who wants to get into process engineering to go help fill the ever-growing gap that we are seeing now and will continue to see into the future?
The best career advice is to ask questions. Ask questions, learn as much as you can, regardless of what you're doing. Just ask questions about what's going on and why. Understand the process. Understand why you're pushing the button. What does that button do? Where does it go? What is and I think from that standpoint, it's critical to just ask lots of questions. If you're starting out in your career, like for me specifically, and definitely not for everyone. When I was in high school, I wanted to make sure I put food on the table. I didn't want to starve. And so I was like, well, what career out there is going to keep food on the table? Science and math. Okay, what science and math we got? Engineering. Okay, let's do engineering. what's the most versatile engineer out there? Do I want to be stuck doing wiring diagrams, or do I want to be stuck? I was like, chemical engineers. Chemical engineers are the most versatile out there. Obviously, I'm biased, so that's why I went to chemical engineering. Is strictly put food on the table and always have a job. But that being said, I work more with mechanical engineers than any other engineer out there, just because the way manufacturing has kind of led, it's a lot of mechanical processes, discrete material handling, conveyors, robots. It's all mechanically driven. So, I think that there's a lot of opportunities for mechanical engineers. Programmers are going to be, they're skyrocketing through the roof. Software as a service, you're paying a monthly fee for everything now because people don't want to sell you anything. They're just going to lease it to you. So all those areas are great tools to kind of focus on. But again, the trades are dying too. If you want to, being a pipe fitter will get you into the process engineering field because you're going to know how things work. Electricians will get you into process engineering because you're gonna understand the invisible aspects of controls. So I think from that standpoint, there's so many areas that you can start in and get into process engineering specifically. But first it's ask questions. You got to ask questions.
Absolutely. I think that's great advice for everyone. We do want to ask, and I realize now that we didn't determine, for a book and or content recommendation. What do you have for us today, David?
Well, so I've read a boatload of change management books before starting my own business. Who Moved My Cheese was a big one, and it's super easy. It's like it's probably like 20 pages. And it's basically just talking about how you manage change. The most recent book I'd recommend is Gap Selling by 𝐏𝐫𝐚𝐭. It's really helped build my business and honestly, everyone's a salesperson. Absolutely, everyone's a salesperson. Mostly you're selling your own ideas to upper management. You're like, hey, I think this will work. It'll be great. And you got to sell it. Prove it out and sell it. And so a big part of that is, gap selling really focuses on where the issues are and focus on what the gap is from current state to future state, and focus there, solve that problem. So I think that's really critical. And I think that I don't really podcast wise, I'm a big fan of Joe Rogan. I'll listen to his podcast. All 3.5 hours of it, it'll just fly by when it's interesting. But that's not really career oriented. That's more of a personal thing when I want to learn more about flying saucers and spaceships.
Any interesting guests like recently that come to mind, David? I'm curious. Joe Rogan?
Not a recent one, but I'm a big fan of Lex Friedman.
Yep.
I know he's one of those other guys that the conspiracy theorists out there, but I like listening to him. It's interesting. Keeps the mind churning.
Awesome.
Absolutely. No, David, this has been fantastic. Last question for you is, how can our listeners help? Who do you want to reach out to you? This is very much kind of your open forum to ask our listeners for anything, conversation, work, anything that way. Wow, anything that way.
No, if quite honestly, if you're going into work fighting fires every day, reach out to us. We do anything from we'll do electrical panel design all the way through full process design. Pumps, pipes, blowers, all that good stuff. TurnerProcess.com. That's the best place to find us. David at TurnerProcess.com. Solutions@TurnerProcess.com. That's our new email now, as we'll find solutions. So
I like it. I like it. David, this has been awesome. If you guys are watching on LinkedIn, which is where most of you find us, or listening on podcast form, we'll have Turner Process Solutions and David's email go listed. Well, if you guys are on LinkedIn, you guys can see them now. If you guys are listening in podcast form, we'll hopefully get all of those links appropriately together and have them in there for the show notes for you guys. And if you guys are watching somewhere else, you guys can absolutely go ahead and see all of that information. David, thank you so much for being here. Everyone, thank you for coming and spending another Wednesday afternoon with us. This has been awesome. We will have to go find a time to literally ask the other half of the questions that we have listed on our show notes document for David, which we'll absolutely do at some point in the future. If you guys have made it this far, make sure you're following David. Make sure you're following Vlad and myself and Manufacturing Hub on LinkedIn, on YouTube, on everywhere else that you're currently listening. If you made it this far on podcast form, or I suppose just in general, please go rate us 5 stars on all of the podcasts that you can go rate us 5 stars on. Please hit the like and subscribe buttons. Please go ahead and share it. Vlad laughs. Vlad laughs. But we have data-based evidence that when I remember to ask people to go do this, people quite literally listen more. So Vlad is going to continue to mock me, but we did get Vlad to go plug one of our own channels last week, episode 163, for the first time ever. Hopefully, before episode 126, we'll get, or 326, we'll get Vlad to do it again. Until next week, we'll talk to everyone soon. Thank you.